Hey Edgar, it's great to see you and finally take a couple minutes to chat through some things about generative AI. I know we've talked through it informally a while, but looking forward to this, man. How are you?
I'm doing all right. Just waiting to answer some questions here on Gen AI, GPT. There's a whole craze, right? So I think it's relevant
It,
for sure.
it is definitely crazy.
Yeah.
Anyways, why don't we get down into some of these questions? One of the things, that we've been really trying to figure out is what is generative AI and really how does it fit into the broader AI landscape?
Mm. Uh, so I think the best way to answer that question is to kind of take a step back and look at, let's starting with AI. Like you got to peel some layers, right? So AI is kind of like the general term, which includes machine learning. Then you have deep learning. Machine learning is mostly like statistical learning. That's how I would consider it. Then you have your deep learning, which are your neural nets. That is like what people are using now to classify images, doing object recognition, detection, tracking. But then that actually serves as like a foundation for the more complex stuff, which is like Gen AI, right? And that's essentially generating content. So in the case of ChatGPT, you have LLMs, these large language models, which are essentially generating text for you, responses for you. But they can also do other things. They can do sentiment analysis. You have, other types of Gen AI, which is not text related, like visuals. I know there's companies that are also doing um, audio generation. Like people are trying to make music using models. So it's it's quite expansive. And then I think there's an effort on like trying to use Gen AI models to actually create synthetic data too, which is a huge issue for the data science community. So
Yeah, I
it's
mean,
got a lot
data.
of applications for sure.
Yeah, I mean, data is a really practical use case, but like you always hear about different things with people making up songs and all kinds of great stuff. So we'll see
That's
where,
I have yet to
yeah,
hear one of those songs, and I'm kind of curious what that would actually look like, or what it would sound like, I should say.
yeah, we'll have to figure that out, man. Well, anyways, looking forward to it. So we were at a conference a couple weeks ago, and obviously generative AI was by far the hottest topic. I had numerous conversations with several folks looking at how to integrate generative AI and really try to understand what it is, but like they always associated it with like OpenAI and ChatGPT. You
Hmm.
spend quite a bit of time with your day job kind of going through this. Like, can you just take a step back and just really try to help us understand like what is this ecosystem and like where can people be exploring technologies? Obviously, OpenAI and ChatGPT is awesome, but what else is out there? What should people really be evaluating? What should they be exploring?
Yeah, I mean, right as of right now, there's a ton of options, right? And like you said, ChatGPT is the one that everyone knows about because it's on the news, like people have been talking about it since it came out, like it blew up, right? So now everybody's like,
No.
I can code now, like it does websites for me, it does this for me. Like there's a bunch of applications. You can go on YouTube and I'm sure you can like learn how to build a website with ChatGPT, right? So there's a huge craze and I guess it's because um, it's a tool that an everyday user can use and they don't have to know how like the models work, right? It allows them to do things they couldn't do before, was very specialized. Um, but there are other options. So there's, after ChatGPT came out, like there's other companies building open sourced LLMs, for example, if we want to stick with LLMs. And one place you can find those is Hugging Face. So Hugging Face is like you can think of it as like a huge repo for models, and you can find the latest models like Llama 2. You can find the Falcon models, the T5 models. There's a bunch of models there, and you can pull those down for free. You can start working with those. There's also another company called Anthropic. I think
Mhm.
their version of ChatGPT is called Claude or something. So
So they
there's
didn't use an animal name. They went with something like human.
yeah, I don't know. I
Yeah.
don't even know what Claude is for. Like when I heard Claude, I thought Jean-Claude Van Damme. So
Yeah. Does it do the
um
splits like in
uh,
the movies?
Yeah, yeah, it does. I've seen it. Um, so there's options. There's also like, and what you decide to use is dependent upon like your goals, right? Like if you're just trying
Mm,
to create, and also how much money and how tech savvy you are, because like if you want to go the route of open source, so they pre-train those models for you, but if you want to make it specialized to your particular application, then you might have to fine tune it, which can be very expensive and extremely time consuming. Because if you don't know what you're doing, you're probably going to spend a whole bunch of money, right? Like these GPUs that are necessary to fit these models on there are massive and they cost a lot of money. It's like $32 an hour, so it can get pricey very quick. Um, but there's other solutions, like RAG, for example.
very cool. So, going back to the whole generative AI piece, a lot of people associate it with this question and answer use cases. Hey, how do you answer this math problem? Can you translate this? What's the capital of this? Like, who's the best sports player? That's always solving different types of debates. We've talked about numerous different use cases over the last several weeks and months, and looking at like cyber or code generation. Are there any other use cases out there that like you're really excited about using generative AI to help like with different problems or challenges?
Mm, I personally am most excited about the cyber piece. I think that that is an industry that's growing, that is going to grow, and it's becoming a very important part of not only like national security because the DoD is like really involved in this stuff, right? And
Hmm.
companies need to also be more aware of like the cyber domain because there's hacks happening every day, right? And your data is your asset. And if you do not have that locked down, then that's a problem, right? So if you can use, AI to help mitigate those things or even, for defense and also for like, post hack, if you will, I think those are awesome use cases because there's a lot of value in that.
Yeah, it's very cool. I think there's a lot of other use cases. I think, language conversion. It's also research, just trying to figure out different pieces. But I think one of the big things that they're trying to figure out
Mm.
is where is like the models trained or where are they trained? And then more importantly, like, are people using them for research documents, white papers, et cetera? That's trying to also figure out,
Hmm.
is it a human that wrote it or is it an AI model? It's something that's going to be
Yeah.
interesting to see how that evolves over the next, you know, several years.
The
Um,
the options are wide, man. I mean, there's plenty of applications. I mean, I'm pretty sure you can sit down and start thinking of like, oh, I can apply it to this, I can apply it to that. So that's
yep.
the power of, this generative AI, and I think that's another reason why people are so excited about it, right? It's like you can think of so many places where you can actually use generative AI. Now whether it's the right thing to do, because you can solve it with something else, that's a different question. But definitely
But
it captures the imagination.
yeah, I think everybody's trying to use it as the new single hammer that fixes everything. So
Yeah. And we
definitely
got
something to
we
be
got our
careful of.
developers using it to build our software too.
Yeah. Speaking of developing, so generative AI obviously is a bucket, right? You work with it and you've evaluated several different models, but in order to make these models like really effective, like what are some of the other tools and processes that are you're finding out there in the market that are really helping accelerate your development life cycles?
Yeah, so um LangChain and Llama Index are two of the most powerful platforms or packages that have come out recently.
Hmm.
And the reason they're so powerful is because the LLM it's a stateless model, right? Which means it does not remember what you've said before. Like if you ask it a question, it's not going to remember anything about what you asked it. So you need to, it's essentially just trained on the data that it's been, you that you were given, that you gave it during training. and that's all the information it has, right? But what you can do now is there's two avenues to make your application. One is you fine tune it. So you can take a pre-existing model, you unlock some of the weights, and then you fine tune those weights, right? There's different strategies to do it, to make the whole process faster. But
Mhm.
again, that takes a lot of know-how from a hardware perspective and from like a training perspective. You need to know exactly what you're doing, or else you're just going to burn money. The other option is retrieval augmented generation, which is where LangChain and Llama Index fit in. So instead of having to train the model, what you do is actually supply the model with external data. And so essentially, there's a system that sits in between the model and your data that allows that that like exchange of information to occur. In that case, it's LangChain, right? And Llama Index. Llama Index is more of like a general framework, while LangChain is more specific to like search and retrieval tests. So
Is that
those are the
external
two that
data
I know.
used? Yeah, is the external data used as part of like interacting with the model, or is it also used when we're training up front? So those are just a couple different things that like I'm trying to help other folks figure out.
What? Can you repeat the question again?
So trying to figure out like when you're talking about external data, is that just like supplementing the data that the model has available to answer the questions, or is that used for the training process?
It's a supplemental data. So
Okay.
when you go with like RAG, which is the like Llama index, it's data. I mean, it wouldn't make sense to give it the training data because then because it already has that information. Most likely, it's able to
Right.
answer that, right? So yeah, it's completely new data. That like for example, let's say um, you wanted to answer questions on like your SQL database, for example, right?
Hmm.
You can hook it up. You can hook up LangChain to an open source LLM or OpenAI, whatever LLM you want to use in the backend, and then connect it to your SQL database and ask it questions about your database, and it will retrieve that information and provide it to you in text form, right? Like so, it's pretty powerful.
It's
But
super powerful.
and the best thing about it is you don't have to train the model, right? So
Hmm.
you have that upfront cost. And LangChain is open source. Llama Index is open source, and then you have open source models. So from a cost perspective, it's probably the best way to go when you start to develop your initial application. Now, if you find that RAG isn't enough to do what you want it to do, then at that point you might want to think about training it.
Really cool. Um, so, as part of the research that you've been doing and like all the different testing, can you give us some insights into some of the different areas of like success and maybe some challenges? Like, I know we've done a lot of research going back and forth between, CPU and GPU and like what works best and different sizes, different numbers of GPUs, just really trying to get, I know we talk about it almost every day, but it's really trying to get like just some sort of summary of like what's going on with your thoughts and research there.
So what I've been trying to do is figure out how we can not only reduce the size of, well, performance essentially, right? So if you take an open source model, usually these are
Hmm.
pretty large. Llama 7 billion is I think like 9 gigs, right? 13 billion
No.
is 16 gigs or something like that. Don't quote me on that one. It's somewhere around there. But point is that they're large models, right? And so
No.
if you put these models on your laptop, for example, or even like on a cloud computer that's only has a CPU, when you ask it a question, it's going to take a while for it to answer because it's such a complex model that there's a lot of calculations that need to occur. And the best way to, well, historically, to do that was to use GPUs.
Hmm.
Problem with GPUs is one, they're expensive, right, to provision.
Hmm.
Number
Hard
two,
to find sometimes too,
they're hard.
right?
Yeah, they're even hard to find, right? Like, we were looking for a specific GPU and like it wasn't popping up on AWS for some reason. I don't know if that had to do with like, demand or whatever, but point is, you don't have the hardware. Um, and I lost my train of thought. So,
Yeah, I mean, if
uh,
you don't have the hardware,
oh, so
you can't
performance.
answer the questions. Yeah. So,
So performance, right? So it takes long, right? So from a user standpoint, it's kind of useless. It becomes a pain in the ass because you're waiting for the answer for like 2 minutes, and depending on the system, like I've tried to run these on a laptop, it takes like 5 minutes, 10 minutes to get a response. That's
it's
not,
terrible.
that is not something that you want a user to go through, right? So what I've been trying to do is figure out ways to not only fit the model onto the existing hardware, whether it be a GPU or if it's like just a basic CPU with some RAM. Um, so fitting it is one. The other is actually getting the inference to be faster. And there's two different strategies to that, right? So like reducing the size of the model can be done by doing quantization, a quantization process. You can use tools like AutoGPTQ for that. I think Onyx also has its own way of doing it. But essentially what you're doing is you're taking the model weights and going from like floating point 32 to maybe int 8, right? So you reduce the size of the model because it takes up less memory um, because of the data type. So that'll reduce the model, right? But then how do you increase the performance or reduce the latency, right? When you ask it a question, how long does it take? The way you do that, and there's several, packages out there, Onyx being another, one of them that does this, is you can compile the model, right? So PyTorch does this natively. It allows you to do it using JIT, and you're essentially compiling the model. Um, but then you have other frameworks like Onyx, right, which are extremely popular, made by Microsoft. And the nice thing about Onyx is once you compile these models, you have like a specific runtime that is optimized for that particular like model that you've compiled. So
Yeah, Edgar and
use,
Onyx is that Microsoft hasn't always done open source. I know they've got various strategies right now. Is Onyx something that's available as part of an open source ecosystem, or is that
yeah,
something that's proprietary?
yeah, it's available. So it's an initiative that is, I guess, the idea was that um, taking a step back, you have all these frameworks, right? Like you have Scikit,
Mm-hmm.
you have XGBoost, you have PyTorch, you have TensorFlow, right? But your hardware, where it gets served, might be different, right?
Mm-hmm.
So the question is like, not all hardware works with those models, right? And so
Right.
how do you develop a framework or a system that allows you to compile your model or put it in such a format that it can be interoperable, right? Like you can put it on any machine. So Onyx is that's the goal of Onyx, is to do that on top of a
It's
couple
cool.
other things. Yeah,
Yeah. Well, very cool. Well, dude, I really appreciate you taking time to answer some of my questions here. I've got one last question for you. You've been, working as a data scientist for a while now and really focusing on a lot of different things, and then also including, the generative AI and large language models. Is there anything that you have from like the lessons learned, like that you wish you would have known going into this, research and work that we've been doing in the last couple months, and just really think it'd be helpful for anybody else that keep them from having to stay up all night trying to figure something out. You know,
there's too many.
there's too many.
There's too many. I don't even know where to start.
Get a good
um,
GPU, man.
uh, GPU, like having the right hardware is um, definitely something that you need to look into. And well, I'll say this. So having, as a data scientist, having a platform or a team that knows how to set up the infrastructure for this is essential, right? Because if not, you're gonna run into a bunch of issues and you're just gonna try to like solve things on your own, and it's so hard, right? Because we
Yeah.
don't, as data scientists, we don't do any of that stuff. Um, so I think having someone who knows how to set up and configure these systems and provide the systems that you actually need to do your job, right?
Yeah.
So for example, if you're training deep learning models, right? Like you could technically do it on a CPU, but it's going to take a really long time and it's going to be a
Yeah.
pain. So having accessibility and like those systems configured for you is definitely something that um, I would say helps ease the pain during the
Yeah.
development process.
Yeah.
um, yeah, that's the
I
first
mean,
thing I could
having
think
a
of.
clean and easy place to work, the clean environment with resources and visibility in those resources, that's got to be game changing versus like sharing different resources or trying to assume what's there, what's not. That's got to make it
Yeah,
hard when you're trying to isolate decisions on what's my code doing, what's the model doing, what are the configs doing, etc.
yeah, yeah. Logging is another big one.
Logs
You have
are
to make sure you log
super important.
because when you're trying to figure things out, the logs will save your life. If not, you're just gonna be like shooting in the dark.
Yep.
So make sure you log things. Make sure the other thing, more specifically to data scientists, is make sure you organize your experiments well and you document these things and have a structure before you start because if you go willy-nilly, it becomes difficult to draw conclusions from your data. So having a plan of attack when you start to actually build and develop models is essential.
It's like a measurable plan of attack is super important, right?
Yeah. Hmm.
All right. Well, awesome. Hey, Edgar, I really appreciate you taking time out of your busy day to answer a bunch of my questions. Hopefully, I can talk you into doing this again sometime soon. Uh, we'll see. It was fun,
Well,
very informative. I think, folks that, take time to watch this will learn a lot as well. So thank you very much.
I hope so. Thank you.
All right, man. Thanks.
Bye.